So I'm Suzanne Stone. I'm from Demartek, and I got to go through a week of, the hard way training with SPEC, SFS, some with Dawn's help. And just to give you some background about what's going on with this presentation is that, as you know, SNIA had asked Demartek to produce some data with our source and power meter and S-flow and everything, because we have that all available in our labs. And in the course of doing so, they asked us for some best practices and lessons learned that we ran into. So this is what we started with is we had done some SPEC SFS a couple years ago, and it had been set up in a Hyper-V environment with several VMs that were connecting to your file storage. And so I just replicated what we did before because it worked back then, and ran into a lot of issues. And in the interest of time, because we were trying to track down these errors and having such trouble, we ended up changing over to CentOS and doing NFS just to get some data out that could be manipulated for data reduction and so on and so forth. So this is, if we're going to do this a second time around, these are the best practices that we would start with and hope that it would work better. If you want to go to the next slide. This is about us. I think I presented on this Tuesday as well. We're a test lab. We don't just do Energy Star. We do lots of lab testing and validation for servers and storage. We are ISO 17025 accredited for data center storage. We don't do that for servers currently, just for storage. We're EPA recognized, and we're on the SNIA Emerald recognized tester list. And of course, in the bottom corner, you have our screenshot from one of our videos that explains to potential customers the process for getting certified using Demartek as your lab. Next slide, please. So here is our best practices based on the pain I went through. First off, when I started with Dawn running SPEC SFS, we ran into some problems with our DNS, and he has mentioned before, make sure your DNS is configured correctly. Now, I did not want to use our production Active Directory and DNS to do this. I went and rolled my own, which is pretty simple in Windows. You just got to install the OS and then add your Active Directory, and when you do that, it'll prompt you to add your DNS in, which is great. But what I forgot is that although DNS sets up a lot of stuff for you and already has a forward lookup zone, it didn't have a reverse lookup zone for the IPs that we were using. And so whenever you added a machine to the domain, it would add it to the forward lookup and not the reverse, so that things weren't completely in that DNS like they needed to be. So I would say, yes, you do want to roll your own Active Directory DNS if possible, rather than messing with your production one, and just keep it on a separate network. It's not using DHCP, so even if you have it on the same network, nothing should be pointing to it except for your test machines. That way you're not messing with anything, because you don't ever want your Active Directory messed up. But I did not start that way, so we had a little bit of problem with DNS. Also, Don made the recommendation that you should have two networks, one for your storage traffic and one for your controller traffic, because each of those load clients needs to connect back to the prime and is going to constantly doing DNS requests to find out where its prime is. So this goes into that again. We did not have that set up that way, and then when you're going and reconfiguring after the fact and changing things around and putting them on different networks to separate them, you're going to mess up your DNS. So that's the other thing we ran into, with just not having it correctly configured to start with, and then when you're changing things around midstream, you're going to miss some stuff. So based on that, this is the recommendation I'd make going forward. First, you have 3 networks. Your first network, again, is your control network. You want that completely isolated. It has your DNS, and if you're using, a SIS environment, Active Directory, and you're going to have each load client with one connection to that, and your prime client connected to that. You're going to want your own DNS Active Directory server, and make sure it's, if possible, highly available, so you might want to make two. And also make sure all of your DNS lookups are working forwards and backwards. Make sure you have that reverse lookup in there. Next slide. Okay, your second network is your storage network. So this is what's going to be connecting to your file storage. You're going to have one one connection from each load client, and of course your storage connected to that, and that's it. So in a Windows environment where the prime client isn't actually doing any load generation, you don't even have to have the prime on that unless it's a Linux network. And then third, I'm including the production network. You need to be able to get into this somehow. So we had one server that you could RDP into that had, a third network on that, so that we could get to it and run things and get to everything else from there. Because, yeah, you need to be able to control this. So that's your production network, your one connection to the production network. Just separate everything else out so you don't have to worry about what other traffic might be going over this network. And, of course, you could make these two isolated networks, your storage and control network, with VLANing or with just a separate physical switch. Next slide. And this is just a summary again. Each storage, if you have more than one file server, should only be on the storage network, and each load client should have two connections, one on the storage and one on the control. Go to the next slide. We've got a little diagram of what I'm talking about. Okay, yeah. Next slide. Here we go. So here I have DNS Active Directory on a separate physical server. We did start off with this on a VM, and I kind of wonder if it was fighting with other VMs. So, and then that is all controlled by one, or connected to one switch that also has one connection to the prime client and each of the load clients. You have one load client that can get back to the production network, so you can control your setup, and then each of those load clients has a connection to a separate network that's connected to your file server. And of course I have the line from your prime client to that storage network dotted, because if you're in Windows you don't even need that connection on the prime because it's not generating any load. It has no reason. Of course, unless you're using a script on the prime client to delete your stores between workloads, then you might want that. So up to you how you want to automate things. Next slide. So yeah, again, when you're making your Active Directory DNS, if you're doing it, instead of using your production one, make sure, you're not making any delegations, you're having a completely separate forest. It doesn't need to connect to the outside world at all. And just deploy it on those two separate networks to start with, so that you're not changing around IP addresses after you've added your load clients to the domain, because then things can get messed up. In fact, at the end, after we did our testing in NFS and made sure that worked and got some data over to SNIA, we went back and redid some of the Windows stuff, and I ended up having to redeploy a new Active Directory DNS because everything was just too messed up from trading around networks and all that. So just start off with the two isolated networks, and then you're good to go from the start. Next slide. So yeah, here we say we eventually switched to a Linux environment, and we choose CentOS, and we said, hey, we've been having a lot of errors, like we would be doing a run and it got through the initialization and several different load points with different business metrics just fine, and then it would conk out. And of course, Don already went into the troubleshooting on that. You're going to look at your log file, and you're going to see which client had the error, and then you can go over to the machine that had that client and look up what that error was. And every single time it was having this DNS error. I can't find my prime client. So how come you can find your prime client for the first 6 business metrics and all of a sudden you can't? Well, we went and we dug out Wireshark and we started looking, okay, what DNS requests are coming in, what's going out. We looked at the DNS VM, and we looked, well, what's the CPU, and so on and so forth on this. And it was getting very low utilization. We weren't seeing any DNS requests that weren't answered. We couldn't figure it out. So we said, okay, we don't know what it's doing wrong, but we'll just switch over to doing DNS on CentOS. So we just grabbed some zone files and started configuring that, and figured out that CentOS 7.4 has a completely different way of configuring your DNS than most other NICs. So if you go to do that, just beware of that little caveat. I don't know if there's any other Linux type of operating systems, any other flavors that have their own way of doing it, but CentOS certainly does, and that completely threw us off. So what we ended up doing for our Linux run was actually just altering the host file of each load client and putting in the name of the prime there with its IP. Not recommended, but if you want to brute force it, that is an option. So again, we just happen to run into all of the random stuff that you never want to run into with this type of thing. Next slide. And here I say virtualization is not recommended, and I'm going to amend that and say that Hyper-V is not recommended. Don was saying, make sure that this control network is completely isolated. So in the end, what I ended up doing was moving my prime client over to the same physical host as my load clients, and then putting them all on an internal network. So there's nothing else there. There's no connection to the outside world. There is no NIC that this is connected to. And still it was having problems with this DNS request. So then that comes down to the hypervisor, and this was a virtual switch inside Windows using Hyper-V. And I've seen multiple examples with people using VMware and doing SIFS testing that way with Windows VMs on VMware. So if I was going to do it with a hypervisor, I would do it with VMware. Also, I would want to look at bare metal deployment, but with that, I'm a little concerned that with just one physical load client that you might not be able to get your full capabilities of your storage tested that way. You might need to add in multiple physical machines that way. But either way, I would just avoid Hyper-V, because what we did when I went back after the fact to run SIFS again, I ran it on bare metal without Hyper-V, and a lot of the issues just disappeared. So, next slide. So yes, a lot of strange errors, like there was not just the DNS error, there was also an error, and when we traced it back, again, it had stopped, after it had done several business metrics, several different load points, a couple hours into the test, and it comes back and says, that it had a file lock when we tracked down the error. Well, the SPEC SFS isn't locking out any files that way, so we weren't sure what was causing that either. But again, when we switched down to bare metal or switched over to NFS, we weren't seeing those. So again, I'm going to blame something with Windows, with virtual switches, or something the like. Again, with this, I don't have all the answers. I'm just telling you the pitfalls that the pits that I went into, so that you can try to avoid them. And yeah, next slide. Yes, and this is back to the DNS failures again. Another point on the DNS failures, I was also seeing that my load clients were getting very high CPU utilization when we're getting those DNS failures. So though Wireshark didn't show any packets dropped with, getting your DNS request back, something was going on possibly with the CPU with those load clients. And so one workaround was to take some of those VMs and put them on another physical host, and that helped get around that problem. So it was something to do with high CPU utilization was causing DNS failures, which is counterintuitive, but that's what we witnessed. Again, not a good explanation as to why, but just what we encountered. Next slide. And I think I already talked about that. Oh yeah, follow the tuning directions. I think Don Capps went into a bunch of tuning that you should do that's in the manual for your NFS setup. Similarly, you want to do a registry hack on the Windows setup if you're doing SIFS to make sure your max ports is higher so that it doesn't limit your connections. Next slide. Okay, now we're getting into just SFlow and how we did SFlow. And I have to give props to the person that programmed into the SFlow collector, the new one that has the Unix timestamp when you're using column format, because we did not have that version of SFlow tool available when we were doing our testing. So we ended up doing, because the column format was missing the timestamp, we had to go ahead and get the full datagram in text form and then use find string or grep to gather the components that we wanted. It wasn't that terrible, but that's just what we had to do. Because it didn't completely fit, SFlow toolkit didn't completely fit what we were looking for, we did investigate some other SFlow collection software and found them just to not be what we needed. I'll go through some of them with you. Some of them has already been presented to you. Next slide. The first one, I think they've already gone over, is SFlow Trend Pro. And even if you're using the trial version of Pro Professional, there's still, like, it seems like a 1 minute is the smallest interval for your data points. So if you need, 10 seconds, or if you want to be like Dawn and do 5 seconds, you're not going to get that. It also is confusing how it's averaging over that minute, or what it is doing there, and so you don't have a lot of control, and you have to do a little bit of digging to figure out what data it's actually giving you. I did find some other software that can also collect SFlow. One is NetFlow. There's a lot of things that will connect both or use both. So one is NetFlow PRTG, and it has up to 100 sensors that can be used for free. Sounds wonderful, but you need to use flow SFlow packets. In case you didn't know, the packets can come in as flow, counter, or extended flow. And so if you're using flow SFlow packets, then that might be an option for you. It does say that the minimum polling interval is 30 seconds, so maybe not. But yeah, you need to be using flow SFlow packets, not counter, and you were using counter. Next slide. Then there's another one that will also do both NFlow and SFlow, which is NTOP NPro. And this has a free trial that runs for 10 minutes in enterprise mode, which is the mode that does the reporting, and then you have to restart in order to run the reporting, or you need to pay a fee. You have one program sending the data to another program, which then displays the results in a nice web interface. So it's very nice looking. We never actually got it to work and figured it probably wouldn't meet our needs anyway unless we paid. So we dropped that one and went back to the SFlow toolkit and just did our greps and find strings. Next slide. So SFlow toolkit, you can take the output and just pipe it directly to a file like Dawn was doing. You can write your own script that'll take the data and automatically put it in the format you want. I'm thinking what I'm going to do next is actually download the new version that has the column format with the timestamp on it, and that would be a very ideal way to do it. So again, props again to the programmer of that. Next slide. And again, this has already been gone over, so I'm going to just go over this briefly. This is going to give you the total, the SFlow toolkit is going to give you the total bytes that have gone in for, ever since you started counting. It's not going to give you a throughput number. It's going to give you a total. So you're going to have to track datagrams from the same port and make sure that you're subtracting, properly the correct datagram from now and the correct datagram from 10 or 5 seconds ago in order to get your throughput. Next slide. So yeah, we found that SFlow toolkit gave us the most control, and yeah, you can just write a script or use grep or find string, or you can download the new version that will give you the timestamp in the column format. Next slide. So if you are looking at raw data from SFlow tools, you can use this handy-dandy formula on this bottom of this slide to convert that from, seconds since the epoch to your actual time. And of course, we were at the time 7 hours off of Greenwich, so we use 7 over 24. You want to use whatever portion of the day you need in order to adjust that. Next slide. Yeah, and again, we were using counter SFlow packets. You can use flow or extended flow, so you need to watch out and make sure that if you're pulling both, that you're not subtracting a counter packet from a flow packet and whatnot. You might want to look and just make sure you're doing things correctly there. I would recommend, only having one type of packet coming from there, either counter or flow, and just having one port from a switch going to one collector, so that you're not subtracting packets that are from different ports, because then you're going to get errors. Next slide. So yeah, there it says SFlow from one port. Now, we only have one port going to our storage, so if you have multiples, I would suggest setting up separate SFlow collectors on separate IPs or separate ports to gather the data from each of your switch ports, so that, again, there's no confusion. Another thing you can do is you'd have to run your a find or something like that to get just the data from the port that you're looking at. Next slide. Okay, I'm going to open this up for questions, but again, just know that I do not have all the answers, just I have the problems that I ran into.
Any questions for Suzanne? Dawn, is there anything you wanted to add to what Suzanne had to say?
No, I think she did a good job.
This is Wayne. So is the recommendation to just go work with the tool that Dawn and you have worked with, or if you were going to go explore and experiment, you should give yourself a week or 2 or 3 to find alternative tools? It looked like you had spent some time reviewing a few and coming up short.
Yeah, a lot of the SFlow tools are based, the GUI ones are based on, if you want to get a general idea of what's going on in your network, go ahead and set up a couple ports, and it'll port back to this tool, and this tool will give you this nice overview of what's going on in your network, which is very useful if you, have that type of a question. But if you want, what was collected at specific intervals, specific times, and want more control, it seemed like the SFlow toolkit was the way to go.
It's also maintained on GitHub, so it's open source and you can get to it easily.
And GitHub, I believe, correct me if I'm wrong, Don, that's the one that has the version that can give you the timestamps in the column format, not the one from...
It will as soon as they accept the pull request. Nick's got the changes there, and he's just waiting for the maintainer to send back an acknowledgement.
Don, are you able to share any insight on other users of the SPEC-FS tool outside of the Emerald program and what they've found with SFlow tools to say, yeah, this is the one?
And the SPEC SFS benchmark, as used by SPEC members, they're looking at the results from the benchmark itself, which is the number of business metrics that you were able to maintain your peak at a certain latency. They're not using any SFlow or any other kind of measurement mechanism, external measurement mechanism. They use the benchmark's results that it provides. So there's not a lot of crossover. There's a huge difference, though, in the meaning between those two different measurement points. In the Emerald, universe, we want to measure the megabytes, okay, per second per watt that's coming and going only to the product under test. So we're literally intercepting traffic at the switch and measuring only what's going in and out of the product under test. With the SPEC SFS results coming from that tool, okay, from the SPEC SFS tool, it's looking at how many of these business metrics can you maintain, okay, and your average overall latency. But it's including in the measurement the client, his protocol stack, his memory, the switch, and the product under test. So there's potential for a lot more things to be involved in the measurement than just the simple product under test that Emerald kind of carves out. So when you're doing the Energy Star measurement, you're trying to get an Energy Star measurement for a particular product under test and not the entire solution that happens to be in the lab. With SPEC SFS, you're looking at the solution and you're not looking at any particular component within that solution. Does that make sense?
It does. Your explanation keeps church and state pretty clear.
Okay.
Does anyone else have any experience with S-Flow on the call that they like to say, hey, this works good, or if I've tried this or that and that didn't work so good?
Well, it quite often gets used for a different purpose. The system administrator who's at a data center, one of the things that they have to deal with is, do I have hot spots in my network? Do I have a particular switch that's being overloaded? Do I have a particular server that's being overloaded? Do I have a particular client who's banging the heck out of some particular segment of my network? That's where they use the high-level GUI interface, and they have the S-Flow collector analyzer tool that analyzes all of the S-Flow data and presents them with a nice graph that says, here's your hot servers, here's your hot clients, here's your switches that are hot, here's the ones that are cold, so that they can then relay out their network so that they don't have those bottlenecks. So quite often it's used for a much higher level, more abstract concept. Here what we're using it for is fine-grained, detailed, specific activity on a given port to a particular server.
Exactly. In fact, a lot of these programs I was looking at, they wanted to get your email address so that, if something went outside the boundaries that you presented, like I want my, throughput on this port to be between this and that, and if it's above that, give me an email to alert me. So it's kind of a more keeping track of how your data center is doing over time than gathering stuff for a Energy Star test.
Right. So we're using S-Flow to get a measurement for a metric, but the average user of S-Flow is an administrator of a large data center who's trying to maintain balance within the entire network structure. There's other features that you also get when you go into the S-Flow family. I mean, we're looking today, this week, we've been looking at S-Flow that's embedded in the switches and is telling us about traffic flow through the switches. There's also another variant called S-Flow Host, where every host machine in the data center is running a piece of software in it that sends out S-Flow packets that are called S-Flow host packets, and it sends those to a collector. Now, embedded in those packets is information about the host, such as how much memory does it have, how many context switches is it doing, what's its load average, how many packets are going in and out of its network interface, how many bytes going in and out of its storage system. So it's giving you a lot of this host information. And again, that goes back to a collector that then people can set triggers on that says, hey, if this host gets above 80%, CPU utilization, or his disk subsystem gets above 90% full, send me an email. And it can literally monitor all of the storage systems, all of the servers throughout an entire data center, and you can monitor it in real time and have it send you alerts if they start to go out of bounds. So it's a very powerful, high-level abstract tool for maintaining and operating a very large, complex infrastructure. We're just using a very small piece of it for our purposes.